All right, so we're going to be going over problem number 42 from chapter 14, which reads, a small earthquake starts a lamppost vibrating back and forth. The amplitude of the vibration of the top of the lamppost is 6.5 centimeters at the moment the quake stops, and 8 seconds later it is 1.8 centimeters. It asks us what is the time constant for the dampening of the oscillation, and B, what was the amplitude of the oscillation 4 seconds after the quake stopped. So what we know is that originally our amplitude is 6.5 centimeters, and that our x max times t, this is the equation we're going to use, is our amplitude times e to the negative t over our time period of, what's it called? The time constant for dampening oscillation. And then what we can do is we can use our equation x, this is another known, that we have our x max of 8.0 is equal to 1.8 centimeters. So what we can do is we can start plugging things in, and that to get to our equation, our time period constant is equal to 8 seconds, negative 8 seconds all over the ln of our 1.8 centimeters from here, and then our 6.5 centimeters from here is equal to 6.23 seconds for part A. Then when we go to part B, we know that t is equal to 4 seconds, and that our time period constant is 6.23 seconds. From there, we can then use the same equation, x max of 40 for our t equals 6.5 for our amplitude times e to the negative t divided by our time constant, so negative 4 divided by 6.23, which when you plug in and do the math, we get 3.4 centimeters.